Hello everyone, my name is Jingting Hui. The topic for my final project is Amazon Fine Food Review Prediction. As nowadays, more and more people start shopping online, and people really start shopping fresh food and grocery stuff online too. And Amazon.com became a very popular place for people to start shopping there. Understanding the review from the customers become a very critical process and methods for the company to determine what kind of food is really popular and what are not, so they can determine if they should increase the safety stock for certain products or they should stop carrying certain items because of the poor reviews from the people. So, understanding the text review from the people to predict the ratings of the items can really help the company to understand better about the demand for the customers and provide a better supply. So that reached to our project statement. I would love to implement the natural language processing techniques on the fine food review text to build a model to predict the ratings and the sentiments. I utilize two approaches. First is binary classifier model, and the second is polarity score model, which I will discuss in details later. And then I show the evaluation for each model I implemented with the data. Let's first take a look about the data. The data of the Amazon Fine Food Review contains over 500,000 instances. So due to the size of the data, I randomly select 50,000 instances as the sample data to do my training model and for this project. The original data wasn't really balanced. We have over 60% with score of 5 reviews. So I selected to get a balanced data, I selected 12,500 instances for each score of review 1, 2, 4, and 5. I didn't include score of 3 because it is more of a neutral review. It is hard to determine if people has a positive or negative sense for the product. Um, for the input data, I use three types of version of input data to run the model. First is just a raw review text data. The next is extracted keywords, and I also used extracted segments. The output is pretty straightforward. It's a binary output. It's a positive or negative, which considers score 4 and 5 as positive and score 1 and 2 as negative. Here we can see the histogram for the text length for each review ratings. As you can see, there are more reviews in rating of 5, and surprisingly, people put more effort writing the reviews when they really like the data, when they really like the product. Um, the text length is way higher when people put the ratings as 5 for the products than people rated the product as 1, which is quite surprising to me because what I thought people potentially would put more text length in review when they really hated data, put more opinion on the product. Here's the word cloud, just to show what kind of words appear more when people put the low scoring review and the high scoring review. So moving to the next step, for the keyword extraction, which I'm going to work on the input data, I implement with the rapid automatic keyword extraction algorithm with NLTK package. Uh, for this algorithm, I identify runs of non-stop words and then score the phrases across the document. The first is the frequency of the word, which is pretty straightforward, just the count of the words in the review text. And the next is the degree of the word, which means it's the sum of the co-occurrence of the word with other words in a given review text. The reason why I'm interested utilizing the keyword extraction instead of the raw review text is because I think it can cut down the noise just focusing on the keywords in the review text. I also concatenate all the keywords in the review text as input data. So here example, the original data shows I will not purchase Ceto Max again until the old formula is brought back. The new stuff tastes terrible. Please bring back the old formula. And what my implement algorithm brought back is the new stuff tastes horrible. Please bring back and not purchase Ceto Max. So it's really just simplify the original text data. The next is segment extraction, as what we did in homework number 5. We know that a complex text can be segmented into different sections, and I'm going to utilize the polarity scores to do the sum or average of all the sections in a certain text. The polarity score can range from -1 to 1, representing negative and positive. Here's an example of the segment extracted from the text file that there is among the best raw bars I've tried yet. So what the segment extracted is a gluten-free diet and it's perfect blend. Talking about the approach, one of the approach I did is the binary classifier. It incorporated with n-grams up to 3. So types of 4 consecutive words are taken into considerations. I have unigram, bigram, and trigram. I also factorize the text and then apply classifier to train the model. So in this approach, I trained the model with original clean text as well as the keyword extraction. This model considered a TF-IDF transformation of the text data, and the classifier I used logistic regression. Here is a quick view of what the model returns. So the features we can see is not is the most negative words, and the disappointed, unfortunately disappointing, are all the negative words, and so they have the really large negative coefficient. Another approach I used is the polarity scores, which is really similar as what we did in homework 5. It used centi-wordnet, compute the polarity of the words, and average the value for the review text. So in this approach, I trained the model using the original clean text, the keyword extraction, as well as extracting segment. I used the whole training text file to run the word-to-vec data and get the positive similar words to the keywords, which I find the keywords running the word count for the entire review text. And I found several words should be really the keywords when we think about the fine food review text, such as products, food, tea, coffee, and drinks. I also run the patterns is a noun followed by an adjective or a verb, adjective, and noun. So move to the evaluation parts. I did the precision, recall, and accuracy call, and also run the time when we run the models, which I think is really big factors when we run a large big of data. So the best I think the results considered time-wise is the binary classifier with extractive keywords. The accuracy almost reached 97%, even though with the entire review text it can be 98%, but I think the accuracy is pretty close. While the time is largely reduced by from 1 minute to 2 seconds. It takes a lot more time when we're running the polarity scores for the text, and relatively the accuracy wasn't as good as the binary classifier did. So here is the future improvement. I think we could improve the segment extraction to tune better patterns, identify and represent a review. Also for the keyword extraction, I think I'd love to incorporate with the text summarization using TensorFlow and Kira to represent better meaningful keywords for the text review, and probably also combining the text review with the summary or the title of the review. Thank you for your time. I'm open for any question you may have.